This lesson is on understanding congruent triangles and what it takes to prove that two triangles are congruent. To start with, congruent triangles are triangles that have corresponding angles that are equal in measure and corresponding sides that are equal in measure. We're going to start out with these two theorems. The first one is the angle-side-angle theorem, ASA. The angle-side-angle theorem says that if two triangles have two angles equal in measure and the included side in between those angles equal in measure, then the two triangles are congruent. So you'll see these two triangles each have their top angle that's equal in measure, and they have this bottom left angle that are equal in measure. And the side that's in between those two angles is also equal in measure. Therefore, these two triangles are congruent by angle-side-angle. The next one is angle-angle-side. This theorem means that you still have two angles that are equal in measure, but the side that is equal in measure is not in between those two angles. So you'll see here the two angles, but it's not the side that's in between them, it's the side out here. It could also be this side over here that's equal in measure. Side angle side says that we have two sides that are equal in measure, and then the angle that's in between those two sides. So this is side, angle, side. That's what we need to prove in order to have them congruent. The last one is side, side, side. If all the sides on this triangle are equal to all the sides on this triangle, then the two triangles must be congruent. It's important to see that that's not true when you're talking about angles. If all of the angles are equal, then you have similar triangles. But if you have all the sides equal, then you have congruent triangles. So here are the four theorems that we use to prove triangles are congruent. Angle, side, angle, so the side needs to be in between the two angles. Angle, angle, side, so the side is not in between the two angles. Side, angle, side, and side, side, side. We're going to look at each set and we're going to tell if there's enough information to prove the triangles are equal, are congruent. So for these two triangles, we have this angle is equal to this angle, and we have this angle is equal to this angle, and we also have a side that is equal. So we have enough information. The question is, which theorem would we use? Well, since the side is not in between the two angles that are equal, it's going to be angle, angle, side. For these two triangles, we have this angle is equal to this angle, and this top angle is equal to this bottom angle, and they don't have any sides marked equal, but we see that the two triangles share that side, and that side is equal to itself. That's the reflexive property. Since that side is in between the two angles that are equal to each other, that's angle, side, angle. For the last one, we see these arrows and they tell us that those two lines are parallel. And then we have this transversal. So we know that this angle is equal to this angle. And we know that this angle is equal to this angle by vertical angles. This angle here is also equal to this angle up here because they're also alternate interior angles. But what you'll notice is we don't have any sides that are equal. So the answer is no, there's not enough information to prove those two triangles are congruent. All right, let's bring this in. Which parts are equal in measure? Which postulate or theorem would you use to prove the triangles are congruent? So let's look at the information that we're given. PQR is equal to the measure of SRQ. PQR, so that's this angle, is equal to the measure of angle SRQ. SRQ, so that's this angle. Those two angles are equal in measure. They also tell us that PQ, that's this side here, is equal to SR. That's this side here. Well, two pieces of information is not enough. So we want to look and see if there's anything we don't see. We're looking at this big triangle here and this big triangle here. Well, they share the side QR. So there's a side and an angle and a side equal to this side and this angle and this side. So they are congruent by side, angle, side. Couple of definitions that you're going to need for some of these proofs. The first one is angle bisector. An angle bisector is a ray that begins at the vertex of an angle and divides the angle into two angles of equal measure. So you know when they tell you you have an angle bisector that this angle is congruent to this angle. That happens a lot. We have triangles and then we'll have an angle bisector, and then we know that this angle is equal to this angle over here. That becomes very helpful. A segment bisector is a ray, a line, or a segment that divides the segment into two equal parts of equal measure. So that makes this side equal to this side over here. Here we have two more overlapping triangles. You see this shape quite a bit. This comes up, and they tell us PL is perpendicular to LA. So we know that this is a right angle. What that tells us automatically is that we are looking at this triangle here because that's what that angle is a part of. Then we know that YA is perpendicular to LA. So YA perpendicular to LA, this is a right angle. So that tells us we're looking at this big triangle. It's helpful to look at them together, but it's also helpful to take them apart and write them like this. So we know that this is a right angle and this is a right angle. We also want to look for anything that they share. We see that they both share the side LA, so we know that this side is equal to this side. That's not enough information to tell the two triangles are congruent. So what I want to know is if I wanted to use side angle side, what else would I need to prove congruent? Well, I have this side and this angle, so I need the side on the other side. So I would need to prove, in order to do side angle side, I'd need to prove this is PL. I'd need to prove that that was equal to YA. And then I could prove they were congruent by side angle side. What about angle side angle? Well, if I wanted to prove these two triangles congruent by angle side angle, I have this angle and this side. I need another angle on the other side, so I'd need to prove these two are equal. So I would need to prove that the measure of angle LAP was equal to the measure of angle, this one is ALY. These exercises in looking for what it takes to prove triangles are congruent helps you later when you're working on proofs, so you can see what you've got and what you need to show is equal in order to prove triangles are congruent.